In a world obsessed with AI's next leap and geopolitical fault lines, there's a silent gold rush happening. Not for physical bullion, but for data. This isn't just data, it's gold dust data, information so valuable it can shift markets, reshape power dynamics, and dictate the future. But just like a prospector panning for real gold, finding true value in this digital deluge requires a critical skill, the art of sampling. What if the very insights powering tomorrow's breakthroughs are built on shaky ground? Imagine a vast, unmapped territory, rumored to hold a colossal gold deposit. This entire territory is our data population. You can't excavate every ounce of soil. It's too expensive, too time-consuming. Instead, you take samples. These small, carefully selected portions of Earth are your data samples, meant to represent the wealth of the entire deposit. The challenge, of course, is ensuring your handful of soil accurately reflects the geological bounty, or lack thereof, of the entire region. In today's hyper-connected world, we're drowning in data. Social media feeds, market transactions, sensor readings, it's an endless stream. Trying to analyze every single data point for AI training or economic forecasting is like trying to mine every single grain of sand in the Sahara for gold. It's impossible. We sample because it's efficient, cost-effective, and when done correctly, can yield insights nearly as robust as examining the whole. The risk? Bad sampling is worse than no sampling. Think of simple random sampling as the quintessential lone prospector, blindly digging a hole anywhere in the vast gold country, hoping to strike it rich. Every location, every potential data point, has an equal chance of being selected. It's straightforward, unbiased by design. But what if your random digs consistently miss the richest veins, the concentrated gold deposits that truly dictate the region's value? It's like training an AI on randomly selected social media posts about gold, only to find it completely misses critical, nuanced discussions from financial experts. Now, consider the seasoned geologist, understanding that gold doesn't just appear randomly. It's often found in specific geological strata, riverbeds, or quartz veins. Stratified sampling divides our gold country, our data population, into these meaningful strata. Perhaps distinct economic sectors, different demographic groups discussing gold investments, or specific geographical regions known for resource extraction. Then, we randomly sample from each stratum. This ensures representation from all critical areas, providing a far more accurate picture of the overall gold distribution, much like nations using detailed geological surveys to assess geopolitical resource leverage. Systematic sampling is akin to a mining operation laying out a precise grid across a concession, taking a core sample at every 100 meters. You select a random starting point, then pick every nth data point thereafter. It's simple, structured, and can be efficient. But here's the catch: what if the gold veins, or crucial data patterns, themselves follow a periodic cycle that aligns perfectly with your sampling interval? You might consistently hit a rich vein, or consistently miss it, leading to a wildly skewed estimate of the actual gold. In an age of digital surveillance, systematic data collection can easily fall prey to these hidden biases, misrepresenting public sentiment or market trends. Sometimes, gold isn't evenly spread but exists in distinct clusters, specific mining camps or entire river systems known for alluvial gold. Cluster sampling involves randomly selecting entire groups, or clusters, of data points, rather than individual ones. Imagine selecting a few major gold-producing regions and analyzing the data within those chosen regions. This is often more practical and cost-effective for large-scale data collection efforts, like surveying economic activity across entire cities rather than individual households. However, if the chosen clusters aren't diverse enough, the entire sample could misrepresent the true economic landscape. But even the most sophisticated sampling methods can stumble upon fool's gold, data that looks valuable but is actually worthless or misleading. Common pitfalls include non-response bias, where certain groups, perhaps those holding substantial gold assets, are less likely to participate, skewing the results. Or selection bias, like a prospector who only ever digs where gold should be, ignoring vast, unexplored territories. Then there's data contamination, corrupted sensor readings, inaccurate historical records of gold prices, or social media bots distorting public opinion. These errors, if unchecked, can lead to AI models making disastrous financial predictions or geopolitical miscalculations. The stakes of poor sampling are immense. Imagine a nation basing its entire economic strategy on a flawed survey of its gold reserves, leading to misallocated investments and national debt. Or a hedge fund making multi-billion-dollar trades on gold futures, relying on market sentiment analysis derived from a biased social media sample, only to face catastrophic losses. In an era of economic uncertainty, flawed data insights don't just lead to minor missteps. They can trigger market panic, erode investor confidence, and destabilize entire economies. As we relentlessly prospect for digital gold, the ethical dimensions become paramount. Just as historical gold rushes often exploited indigenous lands and labor, today's data extraction can infringe on individual privacy and autonomy. The gold of personal data, collected without explicit consent or used for manipulative purposes, raises profound questions. Geopolitical tensions often arise from debates over data sovereignty. Who owns the data collected within a nation's borders, and how should it be sampled and shared? Responsible sampling isn't just about statistical rigor, it's about respecting the source of the gold itself. The paradox of AI is fascinating here. AI can revolutionize sampling, using advanced algorithms to identify optimal data points, predict where gold veins might lie, and even automate the cleaning of contaminated data. Imagine AI analyzing geological patterns to pinpoint the most promising drill sites. However, AI is also notoriously susceptible to bias embedded in its training data. If your initial sampling for an AI model is flawed, perhaps inadvertently favoring certain gold market trends or geopolitical narratives, the AI will simply amplify and perpetuate those biases, creating a dangerously skewed reality. So, as the world barrels forward, fueled by the relentless pursuit of information, the seemingly simple act of data sampling stands as a bedrock skill. It's the difference between blindly digging for fool's gold and systematically unearthing true, invaluable insights that can navigate economic turbulence, predict geopolitical shifts, and harness the true power of AI. Mastering the art of sampling is no longer a niche statistical concern. It is the critical craft of discerning true gold dust data from mere digital dirt, a skill essential for anyone seeking to understand and influence our complex future.